So I want to find the complex roots fourth roots of radical 3 minus I. So first I have to put it into polar form. So my r is going to equal the square root of radical 3 squared plus 1 squared, which is the square root of 4, which is 2. And my angle, this is x is positive, y is negative, so it's in the fourth quadrant, so it's here. And so my angle is the inverse tangent of 1 over radical 3, which is pi over 6. So it's in the fourth quadrant. My angle is going to be 11 pi over 6. So now I have my original value, let's say w, and that equals 2 times the cosine of 11 pi over 6 plus I sine of 11 pi over 6. And so I want to know what the fourth root of w is, because that's what I'm asking for. So that's the fourth root of 2, and then it's times cosine of 11 pi over 6 divided by 4 plus 2 pi k over 4 plus I sine of 11 pi over 6 over 4 plus 2 pi k over 4. So let's first figure this out. 11 pi over 6 divided by 4 is 11 pi over 24. And so I have 11 pi plus pi, this reduces to pi over 2k. But since it's over 24, I want to rewrite this as 11 pi over 24 plus 12 pi over 24 times k. Now I can find my angles. So I have when k is 0, my theta is 11 pi over 24. When k is 1, my theta is 11 plus 12, or 23 pi over 24. When k is 2, my theta is, now I'm going to multiply by 2, so I have 11 over 24 plus 24 pi over 24, which is 35 pi over 24. And when k is 3, which is the last one because that's n minus 1, my theta is 11 pi over 24 plus 3 times 12, which is 36 pi over 24, which gives me 47 pi over 24. Now I can write my 4 answers. So the fourth roots of w are as follows. It's radical 4, the fourth root of 2 times the cosine of 11 pi over 24 plus I sine of 11 pi over 24. The fourth root of 2 times the cosine of 23 pi over 24 plus I sine 23 pi over 24. The fourth root of 2 times the cosine of 35 pi over 24 plus I sine of 35 pi over 24. And finally, the fourth root of 2 of the cosine of 47 pi over 24 plus I sine of 47 pi over 24. So I have 4 roots. And the cool thing is that they're evenly spaced in the plane.